In this video, I'm going to explain about stereo or space isomerism. Stereo or space isomerism is all about how the ligands are arranged around the central metal ion in space. That is the stereo or space isomerism. Stereo or space isomerism is divided into geometrical or cis-trans isomerism and optical isomerism. Now, only the square planar complexes and octahedral complexes show cis-trans isomerism or geometrical isomerism. In the square planar complexes also, only these four types show the cis-trans isomerism: MA2B2, MA2BC, MAB2 and MABCD, but not the square planar complexes of the type not MA4, MA3B and MAB3. These three types will not show the geometrical isomerism even though they are square planar complexes. Okay, square planar complexes are those with coordination number equal to 4, whereas the octahedral, the coordination number is 6. Okay, so let us come to the type Ma2B2. Example of a complex of the type Ma2B2 is our diamine dichloridoplatinum 2, where your A here is NH3 and your B is Cl. The other two examples are these two. So let us draw the geometrical isomers of this diamine dichloridoplatinum 2, or the cis-trans isomers. So we have the cis-trans isomers, the geometrical isomers, platinum, platinum. So 1, 2, 3, 4. The coordination number is 4. That means there are 4 coordinate bonds. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So now for the cis isomer and the trans isomer, these two are the geometrical isomers. Okay, so for the cis isomer, similar groups should be placed on adjacent positions. See, here we have the adjacent positions, here also adjacent positions for NH3 and Cl. So this one is your cis isomer, whereas for the trans isomer, the similar groups lie opposite to each other. So this is your trans isomer. Okay, in the same way, you can draw the geometrical isomers for these two. These two also are complexes of the type Ma2B2. So let us come to the second type, Ma2BC. Let us draw the geometrical isomers of this one. This is an example of the type Ma2BC, where your A is what? Your A here is Py, your B is NH3 and your C is Cl. So draw the geometrical isomers of this complex. We have two isomers, the cis and the trans. Okay, 1, 2, 3, 4. 2, 3, 4. 4 coordinate bonds. 1, 2, 3, 4. So for the cis and for the trans. For the cis, these two similar groups must lie adjacent to each other. Here we have Cl, NH3. Okay, whereas for the trans, these similar groups must be opposite to each other. So this is your what? This is your trans isomer. So let us come to the another one. Let us draw the geometrical isomers of complexes of the type MAB2. Here, your AB is an unsymmetrical didentate ligand like this one, glycinato. So let us draw the geometrical isomers of this complex. We draw the cis-trans isomer of this complex, platinum, platinum. So we have 4 coordinate bonds. So we have the glycinato, okay, glycinato, this group. So for the cis and the trans. For the cis, we draw in this way. We have NH2, and then the what else? CH2, and then C double bond O, and then we have O. Here also the groups lie adjacent, okay. So we have CH2, C double bond O, like this. Whereas for the trans, interchange this one with this. This one remains as it is. CH2, C double bond O. Here we have O in this way. Now interchange here. C double bond O. We have O, CH2, and then we have NH2. Okay, so this is your trans isomer. Actually, the name is your cis, and then cis di glycinato platinum 2, and this is for this one. For this one is your trans di glycinato platinum 2. Okay, next, complex of the type MABCD, where we have 4 different ligands. So a complex of this type forms 3 isomers. Okay, it forms 3 isomers. Come to this one, the type MABCD. 3 isomers are obtained. We have 2 cis and 1 trans. This is your central metal atom. Okay, so we have 4 coordinate bonds. 1, 2, 3, 4. 1, 2, 3, 4. Cis, and your trans. What can you do here? For A, you can keep it fixed. A. So here we have A, B, C, D. This one is your cis. And then the next, A, B, C, D. And for the trans, it is A, B, C, D. Okay, so you keep your A fixed and you change only the position of the ligands B, C, and D. So these are the 3 isomers given by the complex of the type MABCD. We have 4 different ligands, A, B, C, and D. So this is all about the geometrical or the cis-trans isomers. That's all.